Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about redo buffer cache. So this is the whole, the overall holistic picture of Oracle Server, and we are essentially discussing the memory structure. And in this discussion, we are going to deal with this area, which is called redo buffer cache. So here is another diagram of the same whatever we have drawn there, but I just made simplified of whatever I need. So this is my shared global area. In my shared global area I have different memory structure, and I have redo buffer cache and I have db buffer cache, and this is my file system where I have a redo log file which is called online redo log and my data file. Let's say somebody is going to do insert into table T some value 1, right? And assume that table 2's data block is in this data file. So somewhere here is data block. So the first thing is going to happen, this thing is going to come to the dedicated server process, and dedicated server process is going to compile, parse and all this thing. And after that, what is going to do, it is going to change the database block buffer. This thing will change and write there is a 1. Okay, but it's not going to write immediately to the data file. Okay, so first thing is that is going to change. So the first thing is going to change db buffer cache, and after that is going to immediately change what information it needs to store so that it can redo this thing. So that thing is going to store in the redo buffer cache, right? So just immediately after we change the buffer in the db buffer cache, we are going to store the information to redo this thing. Okay, so that information is stored in the redo buffer cache. Then there is a background processes that is called log writer or lgwr. What lgwr going to do, lgwr is going to write those redo information to the online redo log file. So this is your disk and this is your RAM. Okay, so a log writer is going to write your redo buffer cache information to the online redo on these following 4 condition. Number 1, it will write in every 3 seconds. Number 2, whenever basically you are doing somebody insert and somebody do a commit. If somebody doing a commit, then it is going to write when commit happens. Then the number 3 condition, when is going to write when you remember that we discussed about online redo log files comes into the pair, that log switch happens. Like once this once one online redo log file is filled, then it's going to spill over. That's called a log switch. So whenever any log switch happen, the first thing is log writer is going to write the redo buffer cache to the online redo log file. And the last condition is when this redo buffer cache is 1/3 filled or 1 MB full, whichever is first. Okay, so under these 4 circumstances, like it can do either which one is come first. So on that time, online log writer is going to write from the redo buffer cache to the online redo buffer cache. As you see, that is a very frequently, right? So online, this is going to do very frequently. LG writer is going to write to the read from the redo information from the redo buffer cache to the online redo log, and somebody else is going to some another insert and so on. And here is the block buffer, db buffer cache is going to change, and then redo log redo buffer cache also change, and then redo buffer cache is going to you know those information are going to transfer from the buffer cache to the online redo log file. So one thing that you need to notice, that LGWR is going to write more frequently. Then another process called DB writer. So DB writer is going to write the buffer cache to the data files, but this is a lazy writer, or this is going to write whenever it needs, and a very, it's not going to be that frequently as the log writer, and there is a good reason for that. Okay, why this thing is going to write in a different way or in a different frequency. So if this is understood, this is how this redo buffer cache is going to work. So redo buffer cache plus online redo log file together will always contain the information to reconstruct any of this transaction in case of a media failure, or in case of a, like for example, in case of instant failure. Okay, because using these two things we can always reconstruct what happens to this buffer cache, even if nobody really write that one, and that is the all the mechanism of backup and recovery. So if I see, like, this is on my system, and then the parameter that determines how big your online or uh, your redo buffer cache is log underscore buffer. And then if I see my log underscore buffer, it looks like I have 2 megabyte. Okay, so I have 2 megabyte. My size of the log buffer is 2 megabyte. So if this is the case, now let's consider couple of scenarios. So in scenario 1, let's say I am using a extremely active OLTP system. Extremely active OLTP system. That means I am doing lot of insert, lot of delete, lot of update, and so on my database. Okay, so lots of insert, update, and delete. So if lots of insert, update, and delete is happening, that means I'm really writing this thing very quickly, right? So what I'm saying is that I'm writing 1 megabyte in every one half second. Okay, so that means, so this is 2 megabyte, and I'm writing in half a second, I'm writing 1 megabyte. So if I'm writing 1 megabyte in half a second, that means this condition, according to this condition, I'm going to 1 megabyte full in half a second. That means what I'm going to do, log writer is going to write those things to the online redo log file. Let's assume that log writer to write 1 megabyte from the online redo buffer to the from the redo buffer cache to the online redo log file takes 2 seconds. Okay, so these are all fictitious number. I just want to put those things to make up a case for you. Okay, so this is 1 MB full in half a second, and then after, let's say this is a timeline. So it started at 0, and after half a second my redo buffer cache is 1 megabyte full. Therefore, based on this thing, log writer just started to write. So log writer started to write, but log writer unfortunately going to take 2 seconds to completely write this 1 megabyte which is already filled. Okay, so what happened in 1 second, since I'm writing 1 MB per half a second, so in after 1 second I'm completely filled the redo log file. Okay, but since I have not written this all this thing to the online redo log file, therefore I cannot reuse. That means after 1 second I am not able to reuse my online my redo buffer cache, because I have not completely written the first half of the data. So in that case, what's going to happen, this is going to wait, no transaction is going to be happen, like if somebody is going to insert, then he's just going to wait. He is going to wait until 2 seconds when I have completely rewritten first 1 megabyte of data. So after that I can reuse this person with I can reuse this person for the next 2.5 seconds. Okay, for next half a second I'm going to generate another 1 megabyte, right? So then I can reuse this thing for next half second. Again, after that is going to stop until log writer is going to write this amount of data. So this stops means, like, somebody is basically doing an insert, he's going to wait for that. So this is sometimes is not acceptable. So that means you have two options. Either you buy a faster disk where, like, whenever we are just giving writing something is going to written immediately. Okay, so to solve this your scenario one problem, you need either a faster disk, so that log writer, instead of taking 2 seconds, it can be done in 1/4 of a second. If it can be done in 1/4 of a second, then still we are fine, because we can manage it 1 MB. Or you increase the size of your online redo log file. So instead of 1 megabyte, if I make it 8 megabyte, okay, in that case I'm going to increase increase the size of my log file. So now if that is the case, so the number 2 is increase redo log file. So redo buffer. Increase the size of redo buffer. Let's say we increase the redo buffer to 9 MB. So this is my scenario 2. In scenario 2, what I'm saying is I'm going to increase my redo log buffer to 9 MB. So my log buffer is now 9 MB, and then I'm still going to write 1 MB, like I'm going to generate 1 MB of redo in every half a second. So if I'm going to do 9 MB, right, my redo, so let's just try to draw this. This is my redo buffer. So this is my redo. So this is my redo buffer, and let's say this is my online redo log file. So this is my online redo. So what I'm going to say is that, so when I have 1 megabyte of data here, right, so I'm going to start writing, right? So if I'm going to start writing, so let's take the timeline. So this is 0, this is half a second. In half a second I'm going to write already 1 megabyte, and then assume that I have a faster disk, like, I have a faster online disk, and now the log writer can write 1 MB in, let's say, half a second. Okay, so the transfer rate from the redo buffer to your online redo is half a second. So that means 1 MB generated at 0 to 1, 0 to half, and because of this condition that we discussed, like, because of this condition, whenever is 1 MB fail, then redo is going to write. Okay, so in that case, like, just after half second, I'm going to start LGWR is going to start the fast writing from the redo buffer to the online redo. So it's right, and then within the 1 second I'm going to generate another half megabyte of RAM, half megabyte of redo information, and then after LGWR finishes, so, like, it's going to generate half a second, then it's going to rewrite this thing back. So that means at any point of time, even if I have 9 megabyte of redo, I'm just actually using 1 megabyte or maximum 1.5 megabyte or 2 megabyte. So in that case, 7 megabyte will just, you just allocate the space, and those things just always being ideal. Okay, nobody is using that one. So therefore, just by increasing your log buffer to a high value does not guarantee you a better performance. It depends on how fast you are writing, and from these two scenarios whatever I am showing you, from here you can probably deduce, like, how much your log buffer should be. And then all those things depend. There are a couple of things that you need to calculate how much the log buffer is, that how active, like, if you are not generating 1 MB in half a second, let's say you are generating 1 MB in 5 seconds, then maybe, like, your parameters will be completely different. Okay, so your log buffer is going to be determined by how much redo information is being generated, what is the log writer's speed, how much, how, what is the transfer rate from the redo buffer to the online redo. So those two things together gives you a good idea about how much is a log buffer. And redo is one of the most crucial part of any database operation, because this is what it basically protects your data from getting lost. Like in case of a instant failure or media failure, we highly depend on this online redo log file, and if you do not write this thing properly, then it may happen that you are going to lose some data.